In the previous question of a harmonic oscillator, I think I gave the constant without this pi. So while writing this problem, I found that pi was missing. So please do give the correction in the previous problem. Whenever we use the wave function sin of y or sin of x, we should have a pi along with m omega by h cut. Okay. So next problem is a harmonic oscillator is in the ground state. It is given that a harmonic oscillator is in the ground state. We have to find where is the probability density maximum and what is the value of that maximum probability density. We have to find the value of x at which probability density is maximum. So using the definition of probability density, we have a probability density is psi star psi, that is mod psi square, but we have to find, we are given with the oscillator is in the ground state. That means we have to apply n is equal to 0 in the wave function. So we have a 2 raised to 0 is 1, 0 factorial is 1, again h0 of x is 1. Okay, so we have this part, square root of pi omega by h cut into, the whole raised to 1 by 2 and e raised to minus m omega by 2 h cut x square. So this is our ground state wave function. Almost always you may have to remember this value because if the wave function is not given and if we are asked to see, this problem is such a problem that the wave function is not given. So we should know the wave function and find the corresponding ground state value of it and use in the problem to calculate it. So we have probability is psi star psi, psi 0 star psi 0. That means this square, so actually the power is raised to 1 by 4. Now squaring it, we will have square root of m omega by pi h cut. That means we have constant from psi 0 star and psi 0. So we have this one squared. Then this is also 2 times. We have 2 m omega by 2 h cut minus m omega by 2 h cut x square. That means it is 2 times m omega by 2 h cut into x square. So 2 gets cancelled. We have minus m omega by h cut into x square. Now, if probability is an extremum, the differential of it with respect to the parameter given, that is x, will be 0. This is the normal condition that we usually apply for a parameter to be extremum, either maximum or minimum. So dpx by dx should be 0 if p of x is maximum. That means we have to find the differential and equate it to 0 and find out for which value of x it is getting 0. So I have differentiated it, constant into differential of the exponential means the constant is coming out of it, minus m omega by h cut into e raised to minus m omega by h cut into x square, again differential of the x square value to x. This is equal to 0. So for this to be 0, the condition is that we have an x here. So since we have x here, this x should go to 0, so that dp by dx will be 0. That means probability is maximum at x equal to 0. So here we can apply, this is the probability, here we can apply x equal to 0 to find the second part. What is the value of maximum probability? So when we apply x equal to 0, we will have e raised to 0, that is 1. So we will have only this constant, that is p of 0 is square root of m omega by pi h cut. I think you should know this wave function in order to calculate this type of problem. If we know the wave function, it is an easy problem, because just apply n equal to 0 and find psi 0, then psi star psi, the only calculation is psi star psi, then dpx by dx. Okay friends, now we have another question where there is only one difference with the previous question. The question is the same, but it is given that harmonic oscillator is in the first excited state. So first excited state means we have to give n is equal to 1. Okay, giving n is equal to 1, we have psi 1 of x, then m omega by pi h cut, square root of it, 1 by 2 raised to 1, 1 factorial, the whole raised to 1 by 2, 1 factorial. Okay, then h n of x, h 1 of y is 2 times y, but using the conversion factor, y is square root of m omega by h cut into x. So I have given 2 times square root of m omega by h cut into x. Exponential is the same. So this is our wave function. Now we are going to find the probability, that is psi 1 star p of x is equal to psi 1 star psi 1. So this constant will be squared, that means from both psi 1 star and psi 1 we have this constant square root of m omega by pi h cut 1 by 2, then 2 times m omega by 2 square m omega by h cut, then we have to we have x square e raised to minus m omega by h cut x square. I think you understood. We have contributions of psi 1 star and psi 1, that means the same term is getting doubled, this one twice. So I have removed square root because it is squared, then 2 is squared, square root of m omega by h cut is squared, x is squared, this one is squared, that means it is 2 times m omega by 2 h cut. So it is m omega by 2 times m omega by 2 h cut x square. So I have removed this 2 from here. Okay, now we have to find the maximum value. dp by dx is equal to 0. At which value of x this probability is getting? Probability is at an extremum, that is at a maximum value. So I am not going to write the constants, then differentiate it, x square into differential of this one is minus m omega by h cut into 2x exponential minus m omega by h cut x square plus e raised to minus m omega by h cut x square into 2 times x. So we have to solve for constant, all the constant will be 0. The only thing remains is x cube into constants are 2 times m omega by h cut. From here 2 times minus 2 times m omega by h cut and x cube here. Exponential can be taken outside, so plus 2 times x. Okay. Then into exponential. Exponential minus m omega by h cut into x square is equal to 0. So this exponential and one more 2 is taken common. This can be equated to 0. So only thing remains is the term in the bracket. So what we have is the term in the bracket should be 0. That means this is equal to, this one is equal to x. One of the x can be cancelled. So we have x square is equal to h cut by m omega. Take this one to the right hand side. So x is equal to square root of h cut by m omega. So we have the value of x at which p is an extremum. After differentiating, we have equated it to 0. So we have the condition that at x is equal to h cut by square root of h cut by m omega will have probability value maximum. So let us apply it. For all the x we have to give x square, we have to give h cut by m omega. So here we have h cut by m omega, here also h cut by m omega. These two terms will be cancelled, 1 2 will be cancelled, this is cancelled. It's equal to, will have square root of m omega by pi h cut into e raised to minus 1. We can give a value of pi and e, 1 by e will get this one as 0.415 times m omega by h cut. So that is the maximum value of probability. Now the last problem is that sketch the probability density mod psi square of the linear harmonic oscillator as a function of x for n is equal to 10. This is a higher quantum number, comparatively higher quantum number. Compare the result with that of a classical oscillator of same energy and discuss limit n tends to infinity. So as we know, the wave function psi n of x is given like this, and we have plotted psi n mod psi n square. The bold lines are quantum probabilities and the dotted line shows the classical probability. Since classical probability is inversely proportional to the velocity and it is proportional to square root of m by 2 e minus k x square. So this is just reverse of the quantum probability. Yeah, n is equal to 0, that is 0 point energy. The classical probability is a minimum or almost 0 at the center, but quantum mechanically we have maximum probability to find the particle at the center of the harmonic oscillator. At the origin we can say x is equal to 0, we have x. So classical probability is calculated just opposite as that of quantum probability for small quantum numbers. N is equal to 1, etc. And See, as it progress, we can see that the ripples of the center is getting, the height of the ripples getting decreased. That means the probability to find the particle at the center is getting decreased, and the probability to find the particle towards the sides of the well is increasing. So as n goes to 10 or to a higher number, we can say that the classical probability is, I'll just draw it. This is a part of well. So yeah, this is sufficient. Can go down, it should extend to the, okay, so this is for n is equal to 10. See, you can see the classical probability is actually going like this. That means at the ground state it was almost 0, but now as it progresses, as the quantum number increases, the probability of classical probability is getting increased. And if we give limit n tends to infinity, that means the ripples will be going like almost smaller ones and this one, and the classical value will be almost approaching the quantum value. This is the case of n tending to infinity. That means, as we have learned in the first unit, that is from correspondence principle, we also know that in the limit of higher quantum numbers, quantum mechanical results approach classical results. So harmonic oscillator is an example for demonstrating correspondence principle. So as we can see, both the probabilities are approaching even at n is equal to 10. So when n tends to infinity, both the result give the same value of probability. I have taken this figure from the notes I have given to you. So this can also be asked as a problem from linear harmonic oscillator. I think I have covered almost all types of problems from this third unit. Do all the problems and learn well. And if you have any doubts, please feel free to contact me.